Hey, this is Ramanuj. So after a long time, I got some time to create some meaningful video. So in this video, I'm going to tell you how to create a good Docker file. You know, most of the application nowadays, if you are deploying, most probably you're deploying it to some Kubernetes cluster, and Docker is the first step that you usually get started with. And a lot of people, although they are using Docker and Kubernetes, even in production, but they are not writing the best possible Docker file or the most optimized Docker file. So in this video, I'm going to tell you how to create a well optimized Docker file. So let's get started with a very simple Docker file and a very simple application. So here, for example, I have a simple Java Spring Boot application, and I will just run this application. If I run that application is going to start on port 8080. So let me go to the browser and let's explore localhost 8080. So you'll be able to see that the my app is running. It's very simple, just a landing page, nothing else. Okay, cool. So what I'm going to do right now, I am going to stop that application. So the first step, now if you are watching this video, most probably you know Docker already. If you are somebody who doesn't know Docker, so it would be difficult for you to understand what I'm saying in this video. So I would make a separate series of video wherein I'm going to teach you what is Docker and how to use Docker. Why do you need Docker, right? But this video is for those people who already know Docker, who are already using Docker, who might be using Kubernetes in production, and for all those people, right? So let's actually get started. So what we are going to do, let's build a Docker file, right? So I'm going to build a Docker file over here. New, just a file or a Docker file. Fine. So here I would remove all these things. Cool, right? So in general, in a Java application, what we need an image with Java, right? So I personally use Amazon Corretto. Sorry, I will go with 25, maybe Alpine or JDK. So I'm just writing JDK for time being, right? That's cool. And then what I'm going to do, let's write in work directory. Let's put it in the app folder. That's cool. Now I'm going to copy, right? So copy. What I'm going to copy is from the target. So whenever you build a Java application, you will get the jar files in your target folder. So we'll just write star.jar, any jar file, and I'm going to copy it as app.jar, and at the end I'm going to write the command java -jar app.jar. This is the thing that I'm going to write. So this is the bare minimal, the simplest, the easiest Docker file that you can actually write for a Java application. Now what is the problem? First, and the most important problem in this, right? So I should have the app.jar build, right? So have to build it first. So let's do it, right? So I'm going to build it first. Let's just go to the terminal. I'm just going to the terminal, and I'm just going to build this by running mvn package command, which is going to build that application. And once you build it, what you will get, so if you expand the target folder, so you got this my app something snapshot.jar file, right? So you got this file, and exactly this file will get copied because I've written star sorry, my bad, right? So it should be star or *.jar, right? So any jar file, that means any jar file. So any jar file will get copied as app.jar, and then it will work, right? So seems fine. So I'm going to save it, and what I'm going to do, right? So I'm going to run this, right? I'm going to build this Docker file. So in order to build the image, what I'm going to do, docker build -t, and just give it my app, right? Okay, that's cool, right? So my app, and I'll give a dot. So I'll hit enter, and we'll be able to see that the Docker file is building. So you can see the time, right? So it's taking a lot of time for the first time, and let's see how much time it takes. So you can see that also my internet isn't that fast, so obviously it might take some time for that reason as well. So let's see how much time it takes. Okay, so we have built the Docker image, and if you want to check the Docker images, I'll open the terminal. Let me maximize this. So on this terminal, I can write Docker images. I'll be able to see that I got this my app, right? So I got this my app, and let's just quickly run this. docker run minus d minus p 080 my app, right? Cool. Let's give a name as well. My app, right? So it's gonna start, and let's quickly cross check that if it is running or not, right? So you'll be able to see that it's running, right? The application is running, no problem, everything is fine. Now I'm gonna stop it. We'll delete it as well. Okay, cool. Now let's try to understand what is the problem, right? So I am going to bring the entire thing here to analyze, right? Let's write the existing Docker file over here. So this is the existing Docker file, and let's try to analyze what are the problems that we have with this Docker file. First and the most important thing you try to understand that you are copying the jar file, right? So copying the jar file. Where do you build the Docker file, right? A part of your CI pipeline. Let's suppose you are using Jenkins, you are using GitHub Actions, GitLab CI, doesn't matter. Now your CI server must have this jar file. Now then it would be your responsibility to build the jar file. In order to build the jar file, you must have Java and Maven installed on your CI server, right? So this is one of the thing, right? So you must have Java and Maven installed on the CI server. So this is an additional headache because it has to run the mvn command first to build the jar file, and then it has to copy. This is something that you should always avoid, right? The second problem that you have here, it is not well optimized because you are using this image, right? It has everything. It has the JVM which is needed. Apart from that, it also has all the JConsole, the debugging tools and everything which is not needed while running that application. So how exactly we can optimize it, right? So first and the most important thing that we will do, rather than completing this work in one stage, we are going to build that image in multiple stages. Well, it's known as multi-stage Dockerfile, and how to build one. Let's start with it. So first and the most important thing, I will keep this as it is for now, and I'm going to write a stage over here, right? So let's comment this with something. Okay, let me maximize it so that you can see the screen more clearly. Okay, let me make it bigger, right? So build stage, right? So I'm gonna go build do a build stage, right? So in this build stage, what I need is I need Maven, right? So first, the most important thing is that I need Maven. So I have some official images which I can use from, Maven 3, something like this, right? So we have this 17. I'm not going to use because my minimum I need 25, right? So this is fine. Maven 3.9.4 Xamarin as built, fine. So this is fine. We are going to use, I can use the Amazon Corretto version as well, right? So we have the Amazon Corretto version of Maven as well. So we can use any of them, but let's go with this. And here, what and all things I'm going to do, right? So same thing, I'm going to choose the work directory as maybe /app. And first and most important thing, you will see that I'm going to copy the pom XML file, right? So I'm going to copy the pom XML file first, right? Right. And then this is something I'm not going to do right now. I'll add it later on. So I'm getting some autocomplete suggestion from a GitHub Copilot. So here, that's fine. And next, what I'm going to do, I'm going to copy the source code, right? Copy the source code, right? So src, the source code. And then I'm going to run the mvn command, mvn clean package. And if at all I want to skip test, which is a good idea. Why? Because obviously before building the Docker file, I or the developer must have done a unit test, right? Or in fact, in the CI pipeline also, there would be a unit test stage. So I don't need to run the unit test once again while building that image. So that makes sense. Okay, that is my build stage. That is my build stage. Cool, right? That is my build stage. Now, what I'm going to do right now, this build stage is going to build that image. So I'll get the jar file, right? Now, next, what I'm going to do, I'm going to create the run stage, right? So let's write the run stage, right? This is going to be the run stage, right? So in this run stage, I can do one thing. I can use I don't need to use this Amazon Courier 25 JDK. Rather, I can optimize it to something better, right? So I can just move to JRE. We can use something like JDK Alpine. That is fine. Or in fact, we can use JRE, and what I'm going to have over here, right? So work directory app, that's cool. And then what I'm going to do, this is something that I'm going to change, right? So copy from build, this is the stage, and I'm going to write app target jar, right? So this is fine, right? So why it's showing an error? So there is a mistake from, okay. There's a typo. So you will be able to see that. That's cool. And what I'm going to do right now, let's build this jar. Let's build this one, right? So I'm going to build this. How to build? Same command. Now I'm going to build it again. And this time I'm going to give a different tag, right? So my app v1, right? So let's give a v1. So I'm going to build it with this tag v1, right? And again, it might take some time. Okay, this is not available. So I will write something which is available. So 3.9, probably this is available. I would check. Okay, this is also not available. So I'll write something which is available. Amazon Correcto. I mean, you should go to Dockerfile and find the best possible. So I'm just going to write Alpine JDK, which is the similar image. Now let's try this. So well, it's going to get built. It will take more time than the previous process because previously we had the jar file already. Now the whole thing, the Maven build is a part of your Docker build process. So first it's going to, you can see the console and it's going to build before Docker build, it's Maven build is happening, right? So it's building the jar file first and then it's going to copy it and then it's going to create the final image. And also a very important thing here. So in this, you have Maven, JDK, all such stuff over here. So that won't be a part of your final image, right? So whatever the last stage, right? So the name of the stage is very much arbitrary, right? So I've just given build. It's not a keyword or something which has a meaning, right? So it's just an arbitrary name. You can give any name. So here, how the final, final build works, right? It will consider whatever is there in this stage, the last stage, right? The last stage is, in this case, is the run stage. And in this stage, if you had something like Maven, you had, or, all the POM XML file you had, the entire SRC folder you had. So all those won't be a part of your final image here, right? So this is one thing that you need to remember. Okay. So yeah, you can see that the task is going on. The Maven build is going on. So we will be waiting for some time. And you see that it got built, right? So we got the tag is v1. Let's have a quick look here. Docker images, and you can see that we got the v1. Size is a bit reduced. I can reduce further more bit later, but right now try to understand what is the change that we have done. So in this case, what is going to happen, your CI server doesn't need Java or Maven to be installed in it, right? Now let's quickly verify that if it is running or not. So you can cross check that currently the application is not running. Now I'm going to start it. So I'm going to run the docker run command once again, docker run, and this time I'm going to just change the version of the image, which is v1. Let's run this and quickly let's come here and refresh this. Yes, it's running as expected, right? So well, this is good. What can I do more? Now, another very important thing that might come to your mind, if you look at the Dockerfile here, let me minimize everything. If you look at the Dockerfile here, you might think, oh, am I just a stupid, right? Why did I copy it 2 times? I mean, I could have just copied everything at once, right? So I could have copied the entire thing, the POM XML file, the SRC in one command. Why did I write multiple commands, right? Obviously, multiple commands is taking more time. What is the reason behind it? Well, Docker works in layers, right? And Docker is already very smart, right? Docker is something which is already very smart. It is very smartly designed. So what happens now, you think of it, right? So whenever you are building an application, how frequently you change your dependencies as compared to how frequently you change your code? Most of the time, right? So if most of the time you would be changing your code, you would be adding new features, you would be updating your code, fixing bugs, right? Once in a while, you might add some dependency, remove some dependency, change the version of the dependency. So how Docker works, right? How the caching works in Docker. Docker creates layers. So if every line over here, right? So this is one layer, this is another layer, right? So whenever you make any changes to your code, Docker will understand that, oh, till this point, nothing got changed. That means I don't need to reconsider from here. That means POM XML isn't changed. And you can do one more thing to cache them separately. You can add this, right? So you can just write, run mbn dependency go offline, right? So if you do this, what is going to happen? Even if you make changes to POM XML in some time, so it's also gonna check if the previous dependencies are already available, because it is going to cache them, so that any new dependency you add, only that dependency will be downloaded. It's not going to download all the dependencies once again. That's the reason why we have written this line, right? Okay. So now this time, okay, now what I'm going to do, I'm going to build this Docker image once again, right? So I'm going to build this Docker image once again, and this time we would see some drastical changes, right? Now let's before I build, I'm going to make some coding changes as well, so that I want to show you, right? So what is the impact of coding change, how much time it takes, right? So where do I have code? I don't have much code. Some templates, some static files are there, right? So I'll just go to index.html and I'm going to make some changes here. Let me make it small, right? And I'm going to write one more thing, copy span. I'm going to write this one, right? Version 2, right? Or I'm just writing 2.0, right? It's cool. Okay, let's build it and let's see how much time it takes now. So I'm going to do Docker build, this time a v2, and let's hit enter, right? So I've just added this line, new line, and you see that quickly, you can see that how quick it was, right? So it within 2 seconds, although my application is very small actually, and I've done a very small modification, but no POM XML dependencies were downloaded once again, right? So this is something that I've optimized and which is taking seconds, right? So from some minutes to it has changed to some seconds, right? Now let me verify if that application is running or not. Did we get the new update or not? So I'm just quickly go. So you can cross check right now. Okay, the previous one is already running. So I'm going to stop that. Docker stop, Docker rm. So I'm going to do rm. Cool, right? So what I'm going to do right now, I'm going to start Docker run. This time I'm going to use my v2. Started. Let's go refresh this. Can we see that your Spring Boot application up and right framework status version, right? So we got a new thing, right? It's called version, which wasn't there. You can see it, which wasn't there previously. We got this version 2.0. This is the new change that we've done, and that's cool, right? That's running. That's very nice. Now, can we further improve it, right? Can we further improve it? Well, in terms of build time, in terms of caches, I have improved. Now we can further improve it by adding some security improvement over here, right? So here what happens, right? So you know that whenever you run the container, it's running as root, right? So you get a bigger attack surface where you can actually install anything, run any command, you get the shell access, and you actually can run any super user commands, which I don't want, right? So what I can do over here, right? So I can just change it to user, right, 1000. And also you can cross check right now what is the user. So if you can just go to Docker exec -it, right, my app bash. Okay, bash is not there, so I'll just go to sh is there, and if I go and if I write who am I, right, so you can see that I'm I'm root, right? So I'll be able to see that I am root here, right? I don't want to be the root, so I can do write this first, right? So what I'm going to do, run add group. There's an right. So we're gonna use an user. So I'm just going to add a username app user, right? So this is the custom user that I've created. And next, what I'm going to do, I'm gonna run switch to that user, right? So what I'm going to do, right? So we just write this one, right? So I'm going to build a Docker image once again. I'm going to open the terminal. Let's run the build command again. And this time I'm going to give this v3, right? I didn't make any changes, coding changes or any other changes, right? So it would be very fast. But this time, what I'm going to do, I'm going to run this next. This was showing that whoami is root, right? So I'll just exit from here. I will do docker stop, docker rm, and this, docker rm. And next time I'm going to run docker run, same thing. This time I'm going to use v3. It started docker exec. I'll just go inside, and if I write who am I, it's gonna say app user. Now what is the benefit? Now if I write yum install, something like git -y, let's see, say that yum is not found, right? I can see, right? Okay, I'm using Alpine, so Alpine is apk install, right? Oh, okay, it is apk add, right? It's apk add git -y, unable to open log, permission denied, right? So you'll be able to see that apk add, you won't be able to do that, right? So if you just want to do sudo, and you see that sudo not found, right? So you won't be able to do that, right? So that thing is there. So I'm just going to exit from this, right? Okay, that's clear. Fine. Now I can make it even better. Now you're still having this shell, right? So you can still go to the shell and run some command. Yes, you cannot run some administrative command, obviously, but still you can run some command. So you can write ls, you can see the jar files, and you can run the jar file, right? So you can java -jar, right? app.jar. Let's suppose if you do, right? Well, basically you will be able to run, right? It's not running because it's going to start on the same port, but you will be able to run. So still you got an attack surface that you are having that shell, and you can run that. How can you make it even better, right? So I'm going to tell you, this time you can actually go for something called a distroless image, right? Rather than using this Amazon Corridor 25 Alpine JDK, you can go for a distroless image. They are slim as well, right? So I'm going to build this. I'm going to change it to the distroless images, right? So if I just change it to a distroless image, how exactly it will look like, I'm going to show you. So here I'm going to write from gcr, right? So gcr.io distroless java 25, right? So I hope that's correct, java 25. And if I have something, right, Alpine is there, not sure, right? So I can just use Debian Prof, right? And now the same thing, I don't need to, I cannot run because these commands are not going to work, right? You know why? Because now I don't have shell, so I cannot run a run command over here. So what I can do, rather, we can just write to user, and they come with a user called non-root, right? So by default, there is a user called non-root available here. Just write this, and that's enough. Remaining things are as it is. And this time I'm going to build the v4 version. Of course, it will take a bit more time because I've just changed this, changed the image, right? So let's do this. Oh, there's a problem, right? So there's a problem that it is not available, right? So something went wrong. Java gcr distroless image. Let's Google it out. Distroless Java 25, right? So I would get an image for this, right? So you'll be able to, let's go to the AI mode, and here I'll get this, right? So here I can see that GCR.io Debian 13, right? So it seems that this is available. I'm just going to copy that, and I'm going to bring it here, right? Java 25 Debian 13, right? So this is the one which is available, and let's quickly cross check. If I try to build with app v4, and you see it's gonna build, right? I'll take some time because only for the run stage, right? Build stage, it's not gonna take some time, right? So only for the run stage, it's going to take some time. Okay, few seconds only it will take, right? Because the major part, the dependency download, it is not doing, right? So I got this, the v4 version we got, and now what I'm going to do quickly, I am going to go to this, let's exit from here, clear. And what I'm going to do right now, so I'm going to stop, docker stop, docker rm, right? Okay, and I am going to do something more over here, right? So I'm going to run that application docker run. Let's write docker run command, just write v4 over here, and it got started. We'll do a docker exec command. I'll get inside, and you see that you are not getting it, right? So what it says that sh, you can see that. So it says that you don't have the sh, right? So you are using distroless, so unable to start container process, sh executables is not present, right? So with this, you have reduced the attack surface a bit more, right? So because you don't even have the shell, right? So this and distroless images are well optimized. They are official images, right? So what I can do over here right now, I can check the Docker images, and you will be able to see that the first one, latest one, is actually the first one. Okay, because while building the first one, I didn't add any tag. So this is actually the first one. This is the second version. This is the third version. This is the fourth version, and this is the fifth version. So you can see that using distroless, so we started from 886 MB. And we reduced to 354 MBs. It's not about the size of the image. You need to understand the time that it is taking to build that image. So that has been changed drastically. So in this way, we can reduce the time, we can reduce the size, and we can optimize it for security as well. There are a lot of things. There are a lot of advanced level of caching and optimization we can do. I'm going to show you, right? So the Docker BuildX plugin and how exactly we can optimize the Docker builder to do even further, right? So even better. What if I have multiple application or multiple Docker images which are using similar kind of Maven dependency? So at that point, you need even better level of optimization. So I am going to show you that level of optimization, some advanced level of optimization as well. This was a basic level of optimization which you can do, and also you can optimize the security, or you can secure your images as well. So I hope you liked it, and make sure you are subscribing to my channel to get a lot of good videos on DevOps and Docker, Kubernetes, Terraform, and so on. Thank you so much for watching.